So first of all, very good evening to everyone. Welcome to Tutorix. Today we are gonna we are gonna revise this chapter, circles. Very important chapter. From this chapter, you can expect theorems. So I'm gonna explain different theorems today. I'm gonna explain different concepts related to this chapter, and then I will explain different theorems also. Okay, fine. Should we start? Okay, Adi. Thank you. What do we know about circles? What do we know about circles? Anyone? Is there anything that you want to tell me about circles? No? Can I say circle is nothing but the collection of points which are at a fixed distance from a fixed point. The fixed point is known as center of the circle. Can we say that? Circle is nothing but the collection of points that are at a fixed distance from a fixed point. The fixed point is known as the center of the circle. Can we say that? Adya and Sadaf? Yes. Circle also has diameter and some other points. Yes. So these are different terms related to circles. Diameter, radius, they are having different values. Diameter is what? The longest chord that is passing from the center from one end to another. Radius is what? The line segment joining the center point of the circle with any point on the boundary. Then we have other things also, such as chord, segment, sector, everything. About these things, we are going to talk about them in the next chapter, that is areas related to circles. In this chapter, we are going to limit our knowledge to secant, tangent, how many tangents we can draw from different points, all those things. So now let me start. A circle is a collection of all points in a plane which are at a constant distance, radius from a fixed point. If I'm drawing a circle like this, you can see na, the center point. Once. Now, this is the center point. Every point on the boundary of this circle is at the same distance from the center point. So if I'm joining, uh, sorry, now suppose this is the point on the boundary or the circumference of the circle. If I'm joining this point using a line segment with the center, then this is known as radius. Suppose this is r. The value of the radius is r as of now. This is uh, uh, on the boundary or the edge of the circle is at the same distance from the center of the circle. The center of the circle is also known as the fixed point. Correct? Now, here in this figure, can you observe something? We can see a center, this one. Also, I can see a line. Why I'm calling it that the endpoints consist of two arrows. It means we can extend this line infinitely in either direction. right? Hello. You can hear me now? No, actually, someone is telling me on the other platform. Okay, sir. Awesome. Okay. Thank you. I think Harman. Thank you, Harman. Yeah. Now, one thing is, a part is always smaller than the whole, right? This we understood in the chapter of Euclid's geometry in 9th class. A part will always be smaller than the whole, correct? OR is nothing but a part of OQ. So OR is lesser than OQ, of course, correct? This is one thing. Then OR is equals to OP. Why is that? Why OR and OP are equal? Why we are saying this? Anyone? This is very basic concept that OR and OP are equal. Yes, very good. Because OR and OP are nothing but the radius of the same circle. Radius will always be equal. Radius value will always be equal, no? When we are considering a same circle. So that's why OR and OP are equal. So it implies that OP is also smaller than OQ. OR is smaller than OQ. OP and OR are equal. So it means OP is also smaller than OQ. Since this happens for every point on the line xy except the point P, P is the shortest distance of all the distances of the point O to the point of xy. As I told you that every point on this line will always be at a greater distance than P. P is the only point which is at the shortest distance from the center. Every other point, if we are joining using line segment, then this will be outside the boundary of the circle, and this is at the boundary. So it means this OP is the shortest distance. What do we know about the shortest distance between any point and a line? Shortest distance between any point and a line. This concept we understood in 9th class. See, there can be three type of distance or infinite type of distance. When we are considering a point and a line segment, we can join this point with this endpoint, with this endpoint also. But the shortest distance will always be the perpendicular one. So the line segment which is falling at the 90-degree angle on this line segment from this point will be the shortest distance. The converse of this is also true. The converse of this is also true, that the shortest distance between line segment and a point will always be perpendicular, right? If here I am saying that OP is the shortest distance between this point and this line, then essentially I am saying that OP is the perpendicular to this line xy. Akhand Singh is saying hello. Hello Akhand. How are you? Now, OP is the perpendicular to this line. This is what we need to prove, and this we did. So every tangent, basically every tangent is making a 90-degree angle if you are joining that tangent, the point of contact, with the radius. Then the radius is making 90-degree angle with that tangent. Wherever you want to draw you can draw a tangent. Suppose this is the tangent meeting at this point. If I am joining this point with the center, then essentially I am creating a radius. This is perpendicular. If we are having a tangent like this, this is the point of contact. Join this with the center. This is perpendicular. Anywhere on this circle, if you draw a tangent, that will always be at a perpendicular distance from the center of the circle. This is the theorem. You are going to use this theorem very heavily in this chapter. Sir, can you explain in brief? You want me to explain again? Okay, let me explain that. So this theorem is that the tangent at any point of a circle is perpendicular to the radius through the point of contact. What is the property of tangent? That tangent is going to touch this boundary of the circle at only one point. If we are joining this point of contact with the center, then essentially we are creating the radius, as you can see in this image. This is the circle, xy is my tangent, only meeting the circle at this point P. We are joining this P with center O, then this OP is the radius. According to the theorem, we need to prove that OP and XY at 90-degree angle. How can we prove this? First, let me explain the concept of a point, the distance between a point and a line. So from this point, I can draw multiple distances. If I join this point with this endpoint, then these two line segments, this one also, but the shortest distance between this point and this line segment will always be the perpendicular drawn from the point to the line segment. The converse is also true. The perpendicular drawn from the center to the line segment will always be the shortest distance between these two. Okay. Now, how we are going to use this here? First thing first, everything is given to us, so only one construction we need to do, and that is we are going to consider a point Q anywhere on this line xy, suppose here, and then we are going to join this Q with the center O. This Q is at a greater distance than the radius, no? We can also confirm it because this OQ is going to meet boundary of the circle at this point, suppose R. OR is the radius, so of course OQ is greater than the radius, right? Hello Sohail, hello Anand, trigonometry का question solve कर दीजिए. Actually today in this session we are talking about the circles. I think we did covered the trigonometry. If you want, you can watch that class. If you are having very specific problems, then you can do one thing, you can join our app Tutorix, there you can ask your doubts, then we can solve it for sure. Sohail, do one thing, download the app, the name of the app is Tutorix. Now, see, I told you the concept of the distance between any point and the line segment, no? This OP is nothing but the radius of this circle. OR is also the radius of the circle. So OQ is greater than the radius, correct? That is written here only because OR is lesser than OQ. Why? Because OR is nothing but the part of this OQ. A part will always be smaller than the whole. This is a concept from the 9th class Euclid's geometry. Sir, क्या मैं 10th पास कर जाऊंगा? भाई क्यों नहीं करोगे? बिल्कुल करोगे यार. कोई प्रॉब्लम लग रही है किसी चैप्टर में, आप आओ ट्यूटोरिक्स ज्वाइन करो, हम सॉल्व कराएंगे. अभी भी आपके पास 1.5 महीना है. 1.5 महीने में तो हम ऐसा रेडी कर देंगे आपको कि आप बोलोगे कि 90 प्लस ही ले आएंगे. टेंशन नहीं लेने का दोस्त. अगर कोई भी टेंशन है ट्यूटोरिक्स में आप रजिस्टर करो और बिल्कुल टेंशन मत लो. कुछ नहीं समझ में आता हम समझाएंगे, आप ट्यूटोरिक्स डाउनलोड करो, कोई प्रेशर लेने की जरूरत नहीं है.
ज़्यादा मेहनत तुम्हें करनी है, थोड़ी मेहनत हम भी कर लेंगे तुम्हारे साथ, बट तुम्हें पास क्या, तुम्हें बहुत अच्छे मार्क्स दिला देंगे। मैथ साइंस की तो हम दे सकते हैं तुमको गारंटी। टेंशन मत लो, तुम्हें कहीं पे लिंक मिल जाएगा ट्यूटोरिक्स का। अगर नहीं भी मिल रहा है, ट्यूटोरिक्स सर्च कर लेना ऐप स्टोर पे, ये लोगो है हमारा, इस नाम से एक ही ऐप आएगी, रजिस्टर करो, आप अपना डाउट भेजो, टेंशन मत लो, हम पास कराएंगे। नाउ हियर OR is lesser than OQ, but OR and OP are equal because OR and OP ये दोनों both of them are radius of the same circle, so they are equal. So from here we can conclude that OP is lesser than OQ. Any point on this line will always be lesser than OP, will always be lesser than OP. So it means we can conclude that OP is the shortest distance between this line XY and the center O. Then apply the converse. The shortest distance between any point and line segment will always be perpendicular. So it means this is perpendicular. Correct? Understood? Now, theorem number 2. As I told you, this theorem number 1, you are going to apply this concept in many places in this chapter. So please do remember this. This is very easy. Any tangent is gonna make 90-degree angle with the radius when joined with the point of contact. So this point of contact when joined with the center, so this radius and the tangent, they are always at 90-degree angles. Theorem number 2. As I told you that there are 3 cases. In case you are given a circle and a point can be inside of the circle at the boundary or outside of the circle. If it is inside of the circle, we cannot draw any tangent. If it is at the boundary of the circle, then the theorem related to that case we already understood. Now second one. In this case, the point is at the outside of the circle, not lying inside, not at the boundary, at the outside of the circle. So this is my circle with center point O, this is point P lying somewhere outside. I can draw 2 tangents. We understood this concept. We can only draw 2 tangents from any point which is lying outside the circle. According to the theorem, we need to prove that the lengths of tangent drawn from the external point of a circle are equal. It means that OQ and OR, the length of these two are equal. This one is also very useful, and there are high chances that they are gonna ask you this theorem in the exam. How to prove this? The proof is also very easy. Let me explain. First thing first, we need to do some construction here. What is the construction? I'm gonna join this point Q of this tangent PQ with center O. Then I'm gonna do the same with point R. I'm gonna join point R with center O. Now what? Now I'm gonna join this point P also with O. Correct? Now you can see 2 triangles, POQ and POR. Whenever you are doing a construction in this way, then we are gonna apply the logic of triangles. Congruency we are gonna apply here. Then we are gonna use the biggest weapon of 10th class, CPCT or CPST. So the only thing that we need to prove is that PQ is equals to PR. Okay. The construction you need to write: join OP, OQ and OR. What is OQ? Radius. What is OR? Radius. What is OP? Just a line segment. Now, angle OQP is equals to ORP is equals to 90 degree. This angle and this angle, we are saying that they are equal. They are 90 degrees. Why is that? because we just understood that any tangent is gonna make 90-degree angle with the radius where the point of contact is. Now if you are joining that with the center, then the radius and the tangent is gonna make 90-degree angle. So this is also 90 because this is the point of contact of this tangent. This is also 90 because this is the point of contact and we are joining this with center. Now in right triangles, because they are 90-degree angles, so these two triangles are right angle triangle. So in triangles OQP and ORP, we can see that OQ is equals to OR. OQ and OR are equal because they are radii of the same circle. Yes, they are equal. OP is equals to OP. This side is equals to this side. Yes, of course, common side. Length is equal only. We know according to the concept of RHS, if two right triangles are given and the hypotenuse of these two right triangles and any one of the corresponding sides are equal, then these two triangles are congruent by RHS, right angle hypotenuse side criteria. In these two triangles, you can see na, this is 90 degree, this is 90 degree, so both of them are right angle triangles. So this is the hypotenuse side opposite to 90-degree angle. So for this triangle, this is hypotenuse. For this triangle also, this is hypotenuse. Common side is the hypotenuse for both the triangles, and common side is equal only. So it means hypotenuse are equal, and one of the sides, this side and this side, are also equal. So we can apply the RHS congruence rule here. So it means both the triangles are congruent by RHS criteria. If two triangles are congruent, then essentially we are saying that they are having same shape and same size. If they are having same shape and same size, then all the corresponding parts of this triangle and all the corresponding parts of this triangle, they are equal. If that is the case, then PQ and P are nothing but two sides of these two congruent triangles, and that two corresponding sides. It means that PQ and PR are also equal. Using CPCT, corresponding parts of congruent triangles, and that is what we need to prove. The proof of this theorem is very easy. First, you need to consider two triangles. These two triangles are right angle triangles because this is 90 degree, this is also 90 degree. In both the triangles, we can see that the hypotenuse are equal and one of the side are equal because these two sides are nothing but radii of the same circle. It means these two triangles are congruent. If two triangles are congruent, then they are having same shape and same size. Having same shape and same size means that all the corresponding parts of this triangle and all the corresponding parts of this triangle, they are equal. That is known as CPCT. And using CPCT, we can simply say that PQ is equals to PR. It means that tangents drawn from any point outside the circle, they are equal in length. How many tangents we can draw? 2. So it means both of them are equal in length. Always. You are going to apply this logic also in this chapter. When you are going to solve different problems, you are going to use this concept also. So both the theorems are very easy to prove and they are useful also. Now, everyone did understood this, no? Anyone is having any doubt, please let me know. Anyone is having any doubt? Adya, having any doubt? No. Then the theorem can also be proved by using the Pythagoras theorem. We can also prove this using Pythagoras theorem, a very basic concept. When we are done proving that these two triangles are right angle triangle, so of course we can apply the Pythagoras theorem here, correct? Hypotenuse, they are equal in length. This side is also equal in length. How to find the length of PQ? PQ will be what? PQ square will be PO square minus OQ square. Same goes for PR. PR square will be PO square minus OR square. But we know that OQ and OR are equal. So we can replace the value. So this whole value and this whole value, they are equal. It means left hand sides are also equal. PQ square is equals to PR square. Square square you can cancel out. So PQ is equals to PR. This is also one of the proof. Very easy to. Right? Now, this one. Prove that the tangents drawn at the ends of a diameter of a circle are parallel. So, this is a different concept now. What is a diameter? The longest chord of a circle. What is a chord? A line segment joining the two endpoints. So, if any chord is passing from the center of a circle, that is known as the diameter. Correct? This is the longest chord. Suppose in this circle, this is the diameter AB passing from the center O. Now, according to the statement of the problem, this diameter is meeting at 2 points A and B. If we are drawing two tangents, because from this point A, I can draw one tangent, from this point B also we can draw one tangent, because these are on the edge or the boundary of the circle, and from the boundary of the circle, if a point is on the boundary of the circle, we can draw one tangent. Suppose PQ is the tangent which we are drawing passing from point A, and RS is passing from point B. These two are tangents, PQ and RS. According to the problem, we need to prove that the tangents drawn at the end of a diameter of a circle are parallel. It means PQ and RS are parallel to each other. Okay, how to prove this? What are the basic properties of parallel lines? Basic property is that perpendicular distance between these two lines will never change. If this is x, this is also x, this is also x. The distance between two lines will never change. They are never gonna coincide each other. They are never gonna diverge on either side. So if somehow I can prove that they are having equal distance between them, then I can prove that these two are parallel. What is the second way? If two parallel lines are there and one line segment is acting as a transversal, then we are having relationship between certain angles, like this angle and this angle. They are forming a pair of alternate interior angles, and the value of alternate interior angles in case of parallel line and transversal is always equal. If this is x, this is also x. Same you can apply here. This and this angle, if this is y, this is also y. So it means pair of angles which are at alternate interior position, they are equal. So if somehow I can prove that this is the transversal, correct? The diameter is acting as a transversal now. If somehow I can prove that this angle and this angle, they are equal in value, then we can prove that the lines are parallel, correct? There's one more concept also. According to Playfair's theorem, two lines are parallel, and if a line segment is acting as a transversal, then angles on the same side of the transversal will always sum to 180 degree. Whatever the value of this angle is, whatever the value of this angle is, But in case of parallel lines, x and y will always sum to 180 degree. It means angles on the same side of the transversal, interior angles on the same side of the transversal will always sum equals to 180 degree. Same goes for these two. They are also equals to 180 degree only, the sum of these two. Now, if I somehow prove that the sum of these two angle is 180 degree, then also we can say PQ and RS are parallel to each other, right? So whatever approach you want to consider, you can do that. Let's see how we are doing this here. Let us consider a circle with center O and diameter AB. First, you need to write everything. If you want full marks, you need to write everything. Let PQ be the tangent at point A and RS be the tangent at point B. This is the image. You are describing this image only, this figure. Now, we need to prove that PQ is parallel to RS. First, since PQ is tangent at point A, PQ is a tangent at this point A, so PQ is perpendicular to OA. Why? PQ is a tangent, OA is this thing. OA is what? OA is the radius. Theorem number 10.1 states that any tangent meeting at the one point of the center, then if we are making a line segment joining the point of contact of the tangent with the center, then that radius and tangent will always be having 90 degree angle between them. So this is 90 degree because OA is radius, PQ is tangent. So theorem 10.1, PQ is perpendicular to OA. Therefore, OAP, this angle is 90 degree. Equation number 1. Now, RS is tangent passing through point B. Point B is on the circle. If we are joining this point of contact B with center O, then we are getting OB. OB is radius. So it means according to theorem 10.1, OB and RS are perpendicular to each other. It means RS is perpendicular. So OBS, this angle is also 90 degree. We are done with this. Look at these two angles. Are they at? वाह यार सर मजा आ गया. Thank you Ansh Mishra. Now, if we are looking at the position of these two angles, then we can clearly see that they are at the alternate position, no? And also they are interior angles. If the values of alternate interior angles are equal, then it means the lines are parallel, isn't it? ऐसा मैंने आज तक नहीं पढ़ा. Thank you भाई. Thank you. So now OAP is equals to OBS. You can also prove that this angle is also 90 degree, this is also 90 degree, they are also at the alternate interior position, they are also equal, correct? So whenever alternate interior angles are equal in case of two lines and a transversal, then the given lines are parallel. So we can simply state that four lines PQ and RS with ABS transversal, these two angles are at alternate interior angles position and they are equal, which simply indicates that both the lines PQ and RS are parallel to each other, and this is what we need to prove. सर एक बार अजय तिवारी नाम का शाउट आउट दे दो प्लीज. शाउट आउट टू अजय तिवारी. I don't know who is Ajay Tiwari, but shout out. Yeah. So we are done with every theorem and the type of problems that you can encounter in board's exam. If you are having any doubt related to this chapter, please let me know. Any doubt, Adya? Anyone having any doubt? No? Okay, anyone from YouTube is having any doubt? You can ask your doubts in the app known as Tutorix. So one thing you can do, Adya, if you want to practice more na about this chapter, then we are having practice exercise in the app itself, and there are almost 50 to 60 problems from this chapter. So you can practice, correct? So if you are having no doubts, then can I take your leave? Okay. So thank you, Adya, for joining. I hope you gained something from this one. I tried my best explaining different theorems, different problems. Even if you are having any doubt na, after this session, you can tell that to us, correct? Then I'm gonna explain that. Yeah. So then I can end this session then. Thank you everyone for joining. Bye bye. Bye Adya. Thank you. So anyone from YouTube having any doubt? Are you able to see the link? Are you able to see the link? Yeah? Let me give you the link. So I'm gonna send you the link here. You can see, no? See, okay, let me speak in Hindi because most of you are using Hindi language. So मैं बता देता हूँ कि अगर किसी को भी किसी भी तरह का डाउट है, ये चीज समझो कि आप लोग ट्यूटोरिक्स ज्वाइन कर सकते हैं. आप लोग सीधा ऐप डाउनलोड करो, अपने आप को रजिस्टर करो, देन हमसे वहां पे सवाल पूछो, हम आपके डाउट्स को क्लियर करेंगे. आपको लग रहा है कि आप नहीं समझ पा रहे हो कोई कंसेप्ट को, हमसे जुड़े, हम आपके डाउट्स को क्लियर करेंगे. बिल्कुल टेंशन मत लो एग्ज़ाम का, अभी भी 1.5 महीना है. ऐप को डाउनलोड करो, रजिस्टर करो खुद को, आओ हम सिखाएंगे. डर लग रहा है पास होने में, हम पास कराएंगे. मैथ और साइंस की तो हम गारंटी ले सकते हैं. डाउनलोड करो ऐप, ज्वाइन करो, अपने डाउट्स पूछो, नहीं तो हम आपको बताएंगे कि कौन से प्रॉब्लम आने की प्रोबेबिलिटी ज़्यादा है, कैसे सॉल्व करने हैं प्रॉब्लम्स. लिमिटेड टाइम ऑफर चल रहा है, जल्दी से ऐप डाउनलोड करो. अभी बहुत कम टाइम बचा है, बट स्टिल हम 80+ मार्क्स तो इजीली स्कोर कर सकते हैं अगर तुम 0 पे भी हो. भी और अगर तुम थोड़ा बहुत भी जानते हो 90 प्लस आएंगे, कर लो ऐप डाउनलोड, भेजो अपने डाउट्स, हम रेडी हैं। थोड़ी मेहनत तुम्हें करनी है, थोड़ी हम करेंगे, ठीक है। हम मिलेंगे अगले सेशन में, तब तक के लिए बाय बाय। डिसाइड करो नेक्स्ट टाइम तक, मैं चाहता हूं आप सब लोग ज्वाइन कर लो ताकि आपके एग्जाम में अच्छे मार्क्स आ सके। हम एक रोड मैप तैयार करेंगे जिसके अकॉर्डिंग हम आपको समझाएंगे चीज़ें, टेंशन नहीं लेने का, पास कराएंगे आपको। चलिए तब तक के लिए बाय बाय। लिंक आपको चैट में मिल जाएगा, ठीक है। मैं मिलता हूँ नेक्स्ट टाइम, बाय बाय।